Okay, in the third video we have people entering an amusement park on a given day, and the people entering are modeled by this function E of t, and then we also have people leaving the amusement park, and that's modeled by the function L of t. And both E of t and L of t are measured in people per hour, where time is measured in hours after midnight. So the functions are valid from t equals 9 to t equals 23, which represents from 9 a.m. to 11 o'clock p.m. And at time t equals 9, there's no people in the park. So the first thing I'm going to do is enter both of these functions into my graphing calculator, which I've done here, just remembering that I have to use x's instead of t's. Now part A says how many people have entered the park by 5 p.m. To do this, which is t equals 17, and round the answer to the nearest whole number, to do this I want the integral of the rate of people entering the park, and that's going to go from 9 to 17. And to do this I'm going to use fnint. First of all, I'm going to clear out to the main screen to fnint, which is option number 9, and I have vars, yvars, function y1, comma x, which is the variable of integration. Then the next thing I enter is the lower limit, which is 9, comma the upper limit, which is 23. Sorry, in this case I want to go only to 17. And I run that and I get rounded to the nearest whole number, 6004. And remember, you have to write the integral notation, mathematical form, and then put the answer. Those are the two things you're required to do for a calculator question. And so we have that there. Part B says the price of admissions to the park is $15 until 5 p.m. So the amount of money raised by the 6,004 people who've entered the park up till 5 o'clock would be 15 times 6,004. The people who enter after 5 o'clock will pay $11 per person, and so we'll multiply 11 by the integral from 17 to 23. And this should give us our final answer of the net revenues and from the whole day. So on our graphing calculator, we're going to have 15 times 6,004 plus 11 times math number 9, which is fnint, and vars, yvars, function y1, comma x, comma 17, comma 23. And when I run that, I end up with $104,044, and that's rounded to the nearest whole number. So that would be their revenues for that day. Part C says let h of t equals the integral from 9 to t of e of x minus L of x dx for times between 9 and 23. The value of h of 17 to the nearest whole number is 3725. Find the value of h prime of 17. Well, h prime of t, by part 2 of the fundamental theorem of calculus, is just going to be the derivative of that expression, which turns out to be just e of t minus L of t, which makes sense. And what that turns out to be is the net rate of which the people in the park is changing. And so h prime of 17 is really just e of 17 minus L of 17. That's how many people have entered the park by 5 o'clock, subtracting out the number of people who have left the park. So on the calculator, that's going to be y1 of 17 minus y2 of 17, and the result is negative 380. And so that turns out to be negative 380